Hey guys, my name's Perry. I'm a web and applications developer from Australia. I'm currently recording in Finland. I moved here with my partner just over 2 years ago now. Okay, so like I said, my name is Perry Mitchell. I moved here from Australia. I used to live on the East Coast in a town called Brisbane. Our summer's about 45 degrees, winters between 10 to 11. Our internet speed is a speedy 20 megabits per second. And I worked for a couple of employers back there doing PHP, MySQL, iOS development, Objective-C, that sort of stuff. A couple of years ago I moved to Finland. The winter's minus 30, the summer is 20 to 25, but the internet is a nice 350 megabits per second and less than half the price. I work for a Finnish-based audience monetization platform called Kioskid. Kioskid is a very multicultural organization with about 10 to 15 full-time engineers. It provides advertising solutions for the web. It's a data-driven platform where we measure our performance based on many different metrics. The advertising platform provides a dynamic ad placement toolkit written in pure JavaScript. So where regular companies would just place their ads statically on a page, we actually dynamically search the page to place the ads in the best locations for maximum monetization. Why I'm here, I love programming. I studied C, C++, C# in university for my microelectric engineering degree. I got employed in my first job doing PHP and MySQL work. I was helping build e-learning systems, which was quite fulfilling. I also got to touch on a little bit of JavaScript at quite an early stage, but didn't obviously have the appreciation for it that I do now. That job position slowly evolved into doing iOS development, Objective-C obviously, doing some large-scale apps for the Australian government and some private firms. And then I was lucky enough to meet my partner, who is a Finnish woman who I moved to Finland with. I got employed quite quickly with Kioskid. I was first trying to be a back-end engineer here, but it worked out better that I was actually doing work in the front end using JavaScript and other platforms like that. What drives me is automation and testing and things like that. I love improving the procedure in which I use to develop the products that I work on. I love automated building, automated testing, deployment to multiple environments, testing and linting. I'm very interested in the prevention of regression, using multiple methods like unit testing, TDD, things like that. I'm a proponent of feature adherence, using strict specifications, code reviews, feature tests, feature specifications. I'm very interested in asset and content optimization, using compression, resizing, converting, things like that. I'm also interested in assisted development, so using functionality like live reloading and file watching during development to speed up the development lifecycle and to make the developer's job as easy as possible. Okay, so what am I going to be talking about today? I'm going to be talking about build tools, and build tools provide a layer of automation and abstraction for the project, where you could easily utilize package managers and repositories to help you develop in the most effective way possible. let's talk about web applications, because I mean that's why we're all here at the moment. So I want to relate my love of building automation to what that means for actually building a web application. We all know that web applications build up of some common components, such as HTML, JavaScript, CSS, and other assets like images and video, etc. So we know that the content, when delivered to the browser, can be minified, compressed. It can be distributed geographically to be close to the clients, for instance. It can be obfuscated for security, content protection, that sort of thing. It can be targeted towards specific browsers and devices for compatibility reasons. It can be polyfilled to support that compatibility. You can have styling prefixes to make it compatible in certain browsers. There may be certain asset formats which are specific, such as different video formats which work on some browsers. And there may be some transpilation happening, where in that the developers might be writing in ECMAScript 6 and converting to ES5, for instance, to be compatible. There may also be different asset quality options, as in different quality videos, different compression levels there. There may also be different asset dimensions, whereas you may have images which are large for larger screen devices and then shrunk down for the lower bandwidth ones. But why do we treat content like this? Why do we merge the content into a form which is much more difficult for us to use? Well, I mean, the answer's simple. It's for the machine. Everyone has one. They come in different sizes, different specifications. Some have fast and slow systems, different processors, different amounts of RAM. They're connected to fast or slow networks. And all of these have an effect on the presentation of our product to the user. The machine doesn't really care about this, but it should receive the optimal format and the best quality for the best experience. So there are a few ways in which developers and systems can ensure that. And first one is code size. The smaller the code size, the more it's compressed, the better the transfer speed. So the better we can get stuff onto the user's machine and it can start running much sooner. So less waiting time. There's also code format, which can ensure how performant the actual system is. Code format again for compatibility. Certain devices and browsers may have different compatibility requirements. Some may be older, some may be newer, and we may change the format of the code to suit a broader range of items there. Asset size, like I mentioned earlier, can be smaller. It can be cut into different portions so as to maximize the throughput and transfer to lower end devices, for instance. The payload, the actual application that we deploy, can be deployed into multiple geographic locations, being closer to the end user. And the closer it is, then the lesser the latency and the higher the transfer speed. And finally, the actual structure of the application. The structure can have a great effect on how easy it is to interact with the content from the front end. So any interactive code like JavaScript, there will be an optimal way to structure your application to ensure that it's the most effective use of the requests. So back to our web apps. HTML. HTML can be minified. So we can strip out the white space. We can reformat it in a way which takes up less space, because HTML, as you normally see it written and indented, is still quite verbose. HTML can also be compressed, gzipped with certain headers and delivered from the web server in that manner. So we can save quite a lot of space there. JavaScript is minified. This is a very, very common practice. I don't think there'd be any massive production level applications which wouldn't have minified JavaScript. It's just common sense these days. There are many different tools to do that. JavaScript can be compiled from many different files using require-based systems, AMD, you name it. It can be transpiled from different formats, ECMAScript 6, level 7. It can also be transpiled from other languages such as CoffeeScript and TypeScript, for instance. JavaScript can also be gzipped and compressed, which is highly recommended for larger applications. Save on transfer time, save on hosting costs. CSS can be minified, so to also take up less space, less white space. It can also be transpiled from different formats and compiled together. So stylus, Sass, SCSS can also be transpiled into CSS. And those can also be compressed assets, once again using gzip or something similar. Assets can be optimized. They can be re-encoded in different formats. They can be interlaced, for instance, for certain types of images. They can be resized to save on size. They can also be compressed. Different levels of compression quality will result in different quality images. They can also be converted to multiple formats. Some formats may be supported on some devices where they're not on others, for instance. Okay, but let's jump in and have a look at HTML. So HTML is a very verbose language, obviously being based on XML. It may or may not be indented, so there's no restriction there, so some HTML can be very, very hard to read, especially minified HTML. There are a lot of superfluous characters and syntax. XML is based on tags, opening and closing, different properties and attributes there. So why would a developer need to write HTML? I mean, the answer is they don't. So, for instance, I like to use Jade in a lot of my projects. Jade is very, very simple to read and requires a lot fewer markings. It's forced indentation, so the readability is ensured somewhat through indentation. It's very expressive. You can see that IDs and classes, you can use the bare minimum amount of markup to get your HTML generated. So there's no need to, for instance, in my example here, to reuse the div keyword when you can clearly specify that you just want a class of main and an ID of feature. A div is the most used element in a lot of these layouts, so Jade can automatically detect that, yes, div is what you're going to be using here with a class of main or an ID of feature. And nesting is performed through indentation. There's also no closing tags, so the amount of HTML Jade you have to write to generate the effective HTML is a lot less, and up to half in some cases. Jade is perfect for view composing in both static and dynamic environments. So when you're generating a dynamic application and you're feeding in different content or composing a HTML file from many different Jade files based on templates and things like that, Jade is very, very powerful at doing that. ES5 or JavaScript in the browser comes in many different flavors, many different formats, but we don't have to write in ES5. I mean, JavaScript is very, very old. We have the ability to write in many different forms. We can write in a more relaxed manner. We can write in ES6 or ES7, for instance, and we can convert that through transpilation into ECMAScript 5. Obviously, in this case, you wouldn't have it unminified, so the ES5 would be minified in production. So we go from a very small amount of code for the developers, which makes sense, to a more machine-orientated approach to using that content. Same with CSS. Quite simple. It's basic. It's definitive. It's static. So you have to mind compatibility between browsers and things like that. You don't have a lot of play with how you actually use the CSS in the browser. But again, you can use another format such as SCSS, which supports multiple functions, compiles to support multiple browsers, through auto prefixing, supports variables and nesting. and then you have your content. So you have your raw format, and then you can convert into your optimized format. Different sizes, different compressions, things like that. So back to our build tools. Build tools help us work in our desired format in development and deliver in an optimized format for the machine. We go from A to B, and we can define that using a build tool so that the process is the same each time we do it. It helps us keep track of the most efficient procedure to do that. And when I'm speaking about build tools, for the front end at least, this can also mean task runners like Grunt and Gulp and things like that. Another benefit to build tools is the use of package managers. So the complex tools are already implemented. We don't have to reinvent the wheel. It's also a reduction in development time, which is a big benefit for many people and many projects, obviously. There's a lot of community support and development being done. There's much less complexity, and there's also much more choice. Grunt, my favorite task runner and build tool, is a configuration-driven utility with over 14,000 modules on NPM. So there's a lot of choice there. I prefer the config-driven approach because I find it much more explicit. But obviously there are another big alternatives like Gulp, which is code-driven and has over 8,000 modules. But you could even go crazy and use just NPM, which is not only a package manager, but it can also act as a task runner. It's a single point of entry with a configuration file, so there's a lot of appeal there. And these tools can help you build and perform a huge array of tasks. They can help you deploy and test and clean your project. I'm going to show you a quick example. We're just going to go over a basic application. It's low complexity. It's based around content and not functionality. The content could possibly be generated by users, and the site is static. So let's jump into that now. So here I've got a grunt file, which I'll show you. The grunt file is actually our build utility. So this is what we use to actually do the building. This is our task runner. And you can see that I've configured many different tasks here for testing, for copying, for cleaning, for CSS processing, etc. And what we're doing here is we're actually transferring possibly user-generated content like Markdown into our final system. We have dynamic CSS through SCSS. We have our unit tests in Jasmine for JavaScript. We have our JavaScript library, which we may be running on the page, and we have our content written in Jade, nice and expressive. So here we can see a list of our available tasks, but we can simply just go grunt to run what we want to run. And that will run through our task and start watching our resources, which means if we were to update one of these resources, it would automatically run and update and reprocess everything. So the task is defined for us, and it'll just keep going in that same manner. And here's our example. So this is our example in all its beauty. It's been generated from Markdown, as you can see. You can generate multiple pages, and we can also use JavaScript to perform different tasks on the page. So very, very easy, very, very simple, and that'll be the same across every developer and every testing system, all using these basic commands. And you can reuse all of these commands necessary to get you to where you need to be, such as a finished testing environment, or the deployment of the website. So you can use the same commands everywhere. I mean, the reusability in task runners and build tools like this is very, very high. Okay, so let's look at what we're doing. We're building a static site. We're developing, we're delivering the static content to static hosting, and the browser accesses the static hosting. Now, this is a very ideal approach because obviously the static files require no overhead processing like PHP or Node.js, so there's no extra memory or CPU usage, which means we can deliver our content to the user much faster, and there's less load on the server, so it should be somewhat cheaper in ideal cases. But this is still not the optimal. We can use build tools to not just deliver us to static hosting, but to split up our content. We can go from dev to our static hosting, and then deliver all of our assets, which would be more beneficial to be closer to our clients, to a content distribution network. So this is a much better system in that it's much more scalable. We could also replace the static content with, for instance, a Node.js application with Express delivering dynamic content, and you can still split out the heavy work to go to the CDN and do the dynamic nature stuff inside the Node.js server. And this can all be done with the same base, and you just change the build tools to assist you to get to that point. Now, build tools help us convert visual markup like HTML. They help us compile and compress various scripts. They help us optimize assets. They help us run tests. They help us compile documentation that's built into your code. They help us deploy assets to various locations like content distribution networks. They help us deploy applications to various areas. There are a huge amount of tools built into Node.js, such as Flight Plan, that will allow you to deliver applications to an endpoint very, very easily with very minimal configuration. But the most important thing of these build tools is that they provide user abstraction. When we're writing code, we're writing it in a way where we hopefully abstract away from the complexity so that we have simple interfaces to interact with the project. The same should be with our project when we're building it, is that we can abstract away from the complexity, define where we want to go, and the build tools will allow the user to interact with the application in the way that the developers intended. But build tools are very, very powerful, and it doesn't just allow us to build things like static websites. We can also build dynamic web services using Node.js or other applications, for instance. We can also now build desktop applications through things like Node.js and Electron, which is very exciting. We can build mobile applications through a huge amount of different tools. We can build browser extensions, so we can automate the creation of all the assets and the manifests for Chrome extensions, for instance, all with build tools. And we can also even build ebooks and documentation. So there are plenty of projects on GitHub where it's an open source ebook, but it's all built using build tools. Jumping into another example. I'd like to show you a desktop application built with Electron. It's very simple functionality. It's code over content, which means we're going to be doing a little bit more functionality here. We don't really care so much about the content. The build process is more centered around how we get our functionality together in a meaningful way for the compilation of the application. And we can use this to ensure that we want to be cross-platform. So we might want to deliver this to Windows, Mac, and Linux users all at the same time. So let's have a look at that. Okay. So I'm using Gulp in this example. Now, there are different reasons you should be using Gulp over Grunt and vice versa. I really encourage you to look at these for yourself. You really should be spending time in both of these and decide which one is better for your work process. And it could be different per project. There's no reason you need to be tied down to just one. These tools are simple enough that you could become an expert in many of them and not have to worry about judgment on that. So here's my basic Gulp file. We're building an application, so we still want to do a little bit of minification and handling of JavaScript. So we want to clean a directory where we actually build from. We want to use Electron, so we have an execution task here. and we want to generate some Jade templates. So I'm still in love with Jade, that I want to use the Jade processing on the actual application. So I've got my template task there, I've got my start task which will do everything for me, so I can actually generate everything from that. So I'm just going to run gulp start and generate an application. Now I'm sorry, I'm actually using a Twitter example here. I mean, this has been played to death, but I think it's a very apt description of how easily this can work. And there you go. So we have a desktop application and we have a bunch of tweets coming through. Simple. And this is now cross-platform, so I can use my build tools to build this for any end platform. Windows even has automatic updates built into this, so the power of this is just endless. So when do we want to use a build tool? This is a very simple question with a very simple answer, and the answer is always. Build tools abstract the build process away from the user. We want to keep the configuration similar between developers, so when developing a shared application across a team, everybody gets the same experience. Everybody can reproduce the same results. They can run the exact same application. This is also important for continuous integration systems and testing platforms. It also makes the whole application faster and safer. Well, I hopefully have convinced you to spend some more time looking at build tools. I really love them. The community is fantastic. There's so much interest and so much going forward. I only really scratched the surface, but there's really so much potential and power and no end to the projects you can use build tooling on. I think you should really strive to start with a build tool and build your application out from there. There's a lot of reading you can do. Obviously, I'm a bit of a proponent for Grunt, so there's some examples here that you can use to check out different Grunt guides and how to deploy using Grunt. And most of those ideas are completely applicable to Gulp and NPM and other systems like that. I would advise, though, that the more complicated your system is, you use more powerful build tools like Gulp and Grunt, and if you're just building a simple application, small command line utilities like even Bash scripts or NPM scripts would be more suitable for those occasions. I'm also very, very active with blogging about these things. I love writing about these different projects and these different build tools, and hopefully you'll find some interest in a lot of my presentations and documentation there. Thank you very much. I hope you enjoy the rest of the conference, and thank you for this chance.